Hello everybody, Brad the Guitarologist here. Today's video is not going to feature a vintage amplifier as per usual on this channel. We have instead a modern Fender Deluxe, one of these Chinese made amplifiers. Was brought to me by a customer in need of repair. I've owned these amplifiers before. They are prone to problems with the capacitors that were used. They used a lot of Illinois capacitors that tended to go bad. I think they got a really bad batch of them that they shoved in a lot of their amplifiers around this time. And so I'll be on the lookout for that. But the bigger issue is the customer said this thing just won't come on at all. So we're gonna hook it up to probably variac first. Dial it up a little bit, see where we're losing our voltages. If that sounds like something you'd be interested in, stick around. One correction before we go any further: this is actually the Hot Rod Deluxe. I think I just said it was the Deluxe, but it's the Hot Rod Deluxe with basically 2 channels and a hot rodded overdrive channel. Which nobody I know of even finds that useful. They usually sound pretty bad on that third hot rodded overdrive channel. I know there are some modifications that other people have done. I've never seen fit to spend much time on one of these modifying it to make that channel sound smoother, but usually they sound really just ice picky, really insect like in their tone. So I usually haven't bothered on this one. I don't know, maybe we'll contact the customer and see if he wants to go further with it, but he said this belongs to a lady in his band, and she only uses the clean channel anyway. So essentially what we're going to do is just try to repair it to the best of our ability, so that she can use her clean channel. So anyway, let's open it up and see what we got on our hands. Okay, here we are with this thing out on the bench. First things first, or just kind of scope everything out. Especially when you've got a complaint of one not even coming on at all. Best thing to do is just kind of start by looking things over to see if there's anything burnt, perhaps. Also, obviously, one of the first things to check would be the fuse, which looks fine, but I'm going to test it anyway, just to be sure. Might as well put it on a meter. Sometimes these can look okay, but they're really not, so it's best to just check them out anyway. Yeah, that one's fine. I already see the meter jumping. Okay, so it's not the fuse. So whatever it is that went did not blow the fuse. Which leads me to believe it may be something simple, because if it was one of the windings on the power transformer, you would think that would take the fuse out. Unless it was the wrong value fuse. I did not check that. It's 3 amps. I'm not sure what this thing's supposed to calls for. I guess it's on the back door. Hang on. Yeah, 3 amp fuse is correct. So that's not it. So the next thing to do would be to start checking for continuity on our windings of our transformer. And the first thing, we're going to grab this black and white wire coming out of this side, because I believe this is definitely going to be our primary over here. So our black wire goes, let's see, goes to P3. And our white wire goes to P4 out of the primary, it looks like. So let's check. Whoop. Let's get a tool. Try to get that out this way then. Okay. Alright. hell's bells? Okay. So we'll set our meter on ohms and just see what the impedance is. Yeah, that's probably about right. So the primary's fine. On the transformer, let's check our main secondary. Not sure without a schematic which one that's going to be. Let's see. Should be one's closest to the. There we go. These are probably our rectifiers, so I'd say it's probably these. I'd say it's that red pair right there. Okay, so this will be our main secondary. And we've got continuity through there, so that's good. So our main secondary is okay. Let's see if it even, I'm going to put it on the variac, see if we get any fire in any of the tubes at all. Check out the light. The light's not coming on until I touch it. See right down here. The light's not on, but I touch it, so there's like a not a very good connection or something on this bulb. I think, you know, is it possible that maybe they were mistaken? And it's just a bad bulb connection and they turned it on, it's like no bulb. I mean, stranger things have happened. I mean, that kind of thing does actually happen, so I don't know. We'll see. But yeah, that bulb right there, that needs to be, that socket needs to be cleaned out for the bulb. Actually, let me back off this and spray that out. Yeah, that's better. Yeah, I've got fire in these tubes. Don't see any in these though yet. And I already have sound. Huh. Hear it? Okay, well, this is going to be an easier fix than I thought. How about that? He said it wouldn't come on at all. It's obviously coming on at all. So here's the clean channel. Maybe it's just that the clean channel's bad or something. Nope. That appears to be working too. So, right. Maybe it was just a bad connection on one of those primary leads. Maybe just taking those off and putting them back on basically got the connection back. Who knows? I mean, it is strange that the bulb was, you know, getting that poor of a connection too. Maybe this thing was stored for a little while in a damp place, perhaps. It has been raining a lot lately. So maybe there was some corrosion or something took hold. At any rate, it appears to be working now, so okay. I will test it out for a little while and see how it goes, but I guess that's going to be it for this one. Okay, I have this Fender Hot Rod Deluxe back up on my bench. Apparently what I had done to it earlier did not work. I had assumed that when I was testing the transformer, I pulled some of these leads off and tested them with my meter and popped them back on, because this thing wasn't even coming on at all. But when I popped them back on, I've turned it on and dialed up on the variac, and it actually did come on at that point. I played it for, I don't know, must have been about an hour while I was watching a TV program, and it acted fine. Give it back to the customer and said, you know, well, I mean, I could go further with this thing, but it's working as it is. So, you know, minimal repair. There you go. So, you know, they played a practice with it. I guess at some point during the practice, it did the exact same thing. It just cut out on them. Wouldn't come back on. So I don't know what's going on exactly with this thing. I have noticed, actually, since having it open this time, one thing that I missed, and that's that cracked, I don't know if you can see it. If you look at right here, this nut on this fuse holder is actually cracked. Shoot, that's actually cracked on both sides. That's cracked all the way through. So I'm going to replace that nut for sure. That's dangerous as hell. Look at that. A plastic nut on that. But yeah, you know, I mean, you can imagine what would happen if that were to pull through. I mean, you get AC right on the chassis. So we're going to unplug these and put a new nut on that for sure. I mean, wow. So that's not good. These are going to need to be replaced. As I kind of suspected last time, you know, I was a bit surprised actually when the thing came back on. And again, I played it for about an hour and I thought, well, you know, maybe everything's going to be okay. And I know that these IC capacitors are not the best in the world, but looking at them more closely, you know, we've got some, what looks like maybe electrolytic coming out of a couple of these at least. So we're just going to shotgun these Illinois capacitors, at least this one, the bigger ones. Also, another thing that commonly fails on these, this one doesn't appear to show any problems, but another thing that commonly goes wrong is these capacitors here overheat this area of the board. That hasn't happened on this one. That area of the board is pretty clean. But I think what I might do is elevate these up off the board a bit. So yeah, let's start with those repairs, because we know we're going to need to do that anyway. So let's just shotgun these, elevate these off the board, and to do that we're going to have to pull this board out. The way that's done is take all the knobs off. There's some screws that you'll find here that I've already removed. You just remove those screws. There's the one I missed back here. Remove all the nuts. Let's see if there we go. Remove all these nuts for all of the controls, and then you can pull this board up and out of here. Alright, we've got the board all lifted up out of here, and we can get a little better look at it. And we want to be gentle with this because you see these ribbon cables here. These will these will either snap or the solders will become weak. So we're just going to be real gentle with it, as gently as we can. But I found the problem, I believe, already. It's right there. You see that? Let me try to get the other side so you can see exactly. That's R11, and what R11 is, that's the, it's like a surge resistor. When you turn the amp on, let's see. Where am I? Okay, let's see if we can get to see it wiggling there. That's like a surge resistor. When you turn the amp on, it just prevents the inrush of voltage. So we're going to resolder that for sure. I think that, because that would cause the problem. And that would make sense that that's the connection. And I've looked at the rest of this board and I don't see any other connections that are loose, so I believe that's probably going to take care of it. And like I said, yeah, that makes perfect sense. I was wrong about those resistors. This area is darkened. You can see there where those big power resistors are. So we're going to elevate those up off the board. And we are going to go ahead and recap this thing so the customer doesn't have to bother with this again for a long time, hopefully. And so, yeah, let's get to that. Okay, I got this thing all back together and fired up, and everything's working just fine now. Replaced the fuse holder, so that has a nice metal collar on it now, or nut rather. Replaced two of these IC caps, the two that were leaky, with other IC caps. Unfortunately, that's all I had on hand that were 500 volts. I think these will be fine. I got these, more recently. I don't think IC caps have been as bad more recently than they were at the time that this amp came out. They were terrible. Whichever batches Fender was getting particularly seemed to be terrible. These I think will be okay. They aren't ideal. They would have been nice to have some F&Ts on hand or something, Spragues or whatever, something that was 500 volts, but I just don't have any at the moment, so this will have to do. I elevated those resistors, added a couple of leads, and then just wrapped the existing resistor leads that was in order to use the existing resistors and elevate those up off of the chassis. As you can see, there's kind of a space anyway when they're manufactured. That's for board mounting these. So these are better than some of them that are just flush, but still, it's a little better. It's not pretty, but they're it's going to do the job. There'll be a little bit more chance for heat to dissipate around those now, since there's a little more air clearance. But yeah, got everything buttoned back up. I think it's all tight and ready to go now. So yeah, thanks for watching this video. I appreciate it. If you guys haven't already done so, please hit the subscribe button. And for now, y'all take care.